Do you see a GCF? I don't. Do you see a quadratic trinomial? I don't. It's a trinomial, but it's not quadratic. We're going to treat it like it is for just a second. I don't see difference of squares. This is in the next lesson, so we're not going to mess with those right now. And it would be similar difference of cubes, and there are no cubes in that one anyway. So why don't we just treat this like a quadratic that's not a quadratic? And you'll see where this is going in a second. So let's just start doing this. And we can come over here with the green pen and talk about what multiplies to give me 36. But first, let's talk about the fact that if this was squared, it would be x times x. But it's not squared, it's to the fourth. So we can just basically say, well, 2 plus 2 is 4, right? In the same way that, here we go, 1 plus 1 was 2. Same thing, same idea, same concept. So 2 plus 2 is 4. No surprises there. We're just talking about exponents. So 36. I need two numbers that multiply to give me 36. Now, I'd love to explore lots and lots of options, but let's keep in mind that I want to be able to add those numbers and get a negative. So two numbers multiply to give me a positive. The signs had better be alike. But I want to be able to add and get a negative, so the signs had both better be negative. So as I explore, I'd say 1 times 36. That's great, but negative 1 times negative 36, right? Okay. 2 times 18. Negative 2 times negative 18. That's what I'm really going for. 3 times 12, negative 3 times negative 12. 4 times 9, that's negative times negative. 6 times 6, negative times negative. Again, put the positive ones if you want to, but they won't be fruitful at all because we're trying to add and get a negative. Okay, switching colors. I want to be able to add and get a negative, 13. Negative 1 plus negative 36 is negative 37, so this one's out. Nope. Negative 2 plus negative 18 is negative 20. That one's out. Negative 3 plus negative 12 is negative 15. That's out. Negative 4 plus negative 9 is negative 13. Found it right there. That's it. Next one will be negative 12, so that's not what I want either. So negative 4 and negative 9, and you can just wash your hands and walk away and get partial credit because this one continues to go. This is, let's go back to our list. No GCF. We had a trinomial that we treated like a quadratic, but now we truly have two quadratics, and they are the difference of squares. We can continue to factor them. That's what we do. It makes waves like that. So here we go. This is x squared, duh, and 2 squared. This is x squared, duh, and 3 squared. We had done this previously on the very second problem, on the second problem of these notes, where we had actually this exact same situation that popped up. And so ignoring this for just a moment, x times x would give me x squared. And then just using the same concept with the green pen, if I had negative 4, I need two numbers that multiply to give me negative 4, but they're going to add together and give me 0 because I have no central middle term, linear term in this case. So I can go through all kinds of things. Negative 1 times 4, 1 times negative 4, negative 2 times 2. Oh, those add to give me 0. That's what I want. So when I said difference of squares, we're just going to jump straight to, oh, the square root of 4 is 2. Put them in a different order sign-wise here than I did there, but it's no big deal. Okay, same situation here. I'd love to list all the things that multiply to give me 9. I'm not. X times x. Positive 9 and 1. 9 and negative. Positive 9 and negative 1. Negative 9 and positive 1. Blah, 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 blah. Who cares? 3 times 3 gives me 9. Positive 3 minus 3. Positive 3x minus 3x gives me the 0 that I didn't even see in the middle anyway. And that's it. Okay. Let's jump to the next one, and the next one is a little bit crazy. And again, we always look for a GCF first. So I have 64x squared minus 49. And do I have a greatest common factor? And it might take you a minute to look at it and say, oh, well, maybe I do, maybe I don't. Okay, first of all, no GCF in terms of variables, right? So x, no x, don't play with those, okay? Is there a number that goes into 64 and 49 other than 1? Nah, that's 7 times 7. 7 doesn't go into that. And those are my only options for that other than 1 times 49. So we are left with, well, no GCF. It's not a trinomial. Maybe it's the difference of squares. Okay? Is 64 a perfect square? Yes, it is. It is a perfect square. It's 8 squared. And 49, is it a perfect square? Yes, it is. So we're going to just factor it that way. Now, this looks like a situation where we would come over here and say, what multiplies to give me negative 49? What multiplies to give me 64? Don't. Please don't. Obviously, x times x. Two things multiply to give me 64. Always go for the square root first, if you can. Two things multiply to give me 49. Always go for the square root first, if you can. But two things multiplied to give me negative 49. So it had to be a positive and a negative. If you were to multiply all this together, and I will in purple to check my answer, I'd multiply 8x times 8x and I'd get 64x squared. So far, so good. 8 times negative 7 is negative 56x in this case. Positive 56x. You see where this is going, right? And then minus 49, 7 times negative 7. And these would cancel, which leaves me with just that to start with. So this was truly my answer.